Hello, in today's video we're going to be taking a look at Microsoft Entra Private Access, which has been dubbed the modern alternative to a virtual private network, or VPN for short. The solution has recently become available in public preview, with some of its features still locked behind a private preview. So everything we'll be taking a look at today in this video is the solution in its current public preview state. So, is this the VPN alternative that we've all been holding out for? Let's take a look together in this video, where we'll look at deploying, configuring and testing the solution for Windows endpoints. So what is Microsoft Entra Private Access? Well, if you didn't know already, Microsoft have recently announced their new security service Edge solution, which fundamentally comprises of two solutions, one being Microsoft Entra Private Access and the other being Microsoft Entra Internet Access. The prior offers a modern cloud-based alternative to VPN connections to provide that much needed access to internal and on-premises resource when working remotely outside of the office, and the latter offers a cloud-centric proxy service for the wider internet. The SSE solution also encompasses Defender for cloud apps and bridges that previously treacherous gap between network access and identities by fully integrating with Microsoft Entra and Conditional Access. As we've grown to expect with anything Microsoft Cloud orientated, the solution leverages a single pane of glass approach and also ensures a zero trust approach to securing, validating and managing network access. The technology behind traditional VPNs, which has long enabled workforces to conduct their work activities remotely outside of a local area network and away from physical offices, has, in the context of technology, served as a fair and commendable amount of time. However, with the inevitable advent of time, organizations have started to migrate their applications, data, users, and devices to the cloud. So the requirement for such a capability has declined, there's no doubt about it. However, this hasn't completely subsided for everyone. And yes, we are talking about those dreaded printers, that last line of business application, or that dreaded file server that nobody dares entertain for migration. There's no doubt that VPNs have served an invaluable purpose today, that's for sure. We only have to look at the work from home movement during the COVID-19 pandemic to find solid proof of this. However, no matter how well the technology has served us previously, we cannot be blinded to its flaws today. VPNs are usually ambiguous in terms of the access that they grant an end user, as they are typically deployed in a non-granular fashion due to their limitations. So rather than scoping the connection to a specific service or application, they rather grant full network-wide access as if the end user was sat in the office. Additionally, aside from enforcing a mediocre method of multi-factor authentication for the VPN connection itself, the controls are far less comprehensive to the point of being incomparable when compared to what Conditional Access can offer us. And speaking of Conditional Access, with the added ability to integrate seamlessly with Entra Private Access, we can significantly secure access to internal and private resources on both an ambiguous and granular scale. If we consider Entra or Azure Application Proxy for the moment, which publishes internal web applications to the cloud, we could always target conditional access policies at those published applications. Well, the same concept applies to Entra Private Access, but with the extended support for additional resources such as SMB access to file servers, where we could, for example, place MFA and compliance controls in front of. And finally, if you've ever had the delight of implementing a VPN solution before, you'll know all too well that it's not always straightforward depending on the solution and the environment that you're working within. As you'll see in this video, Microsoft Entra Private Access greatly simplifies the work and upkeep required to provide remote access to on-premises and internal resources for your end users, all whilst improving security. Now that we all have an initial understanding of the Microsoft Entra Private Access solution, let's now take a look at the prerequisites for it. So, starting with licensing requirements for Entra Private Access. Whilst the feature is in public preview, as it is today, only a Microsoft Entra ID P1 license type is required. We are still uncertain about how the licensing model will look once the solution transitions into general availability though, so I'd recommend that you keep up to date in this area as it all could change. Regarding devices and endpoints, as we're covering Windows here, devices must be running Windows 10 or 11 and it must be a 64-bit version too. The device must also be hybrid Entra ID joined or fully Entra ID joined. Regarding servers that will host the private access network connectors that we'll discuss later in the video, the server must be running at least 2012 R2 at minimum. Looking at network requirements, there are ample URLs that need to be made accessible from the servers if not already, and those servers are the ones that are destined to host the private access network connectors, and the connectivity is required on an outbound basis using ports 80 and 443. I will provide a link in the description for the list of URLs that are required. This next prerequisite heavily depends on your organization's infrastructure and environment. But if you'd like to take advantage of the single sign-on capabilities for internal and on-premises resources, such as an NTFS file share and server, from an Entra ID joined endpoint, the relevant user objects accessing that resource must be in scope for Entra Connect, also known as Azure AD Connect synchronization. So basically, the users must be synchronized. Now that the prerequisites have been covered, let's jump in to actually configuring and deploying the service. So the first step in the process oversees the initial enablement of the global secure access solution in the tenant. Starting off in the Microsoft Entra portal, entra.microsoft.com, we're going to navigate to and then expand the global secure access menu option on the left hand side. Within there, we're going to click Get Started. Within the Get Started page, we're going to refer to section 1 first to make sure that we have met the correct prerequisites. We can see here that we have the correct administrator role to activate the service, and we can also see that we have the correct licensing assigned as well. Because we've met those prerequisites, we can then transition onto section 2 where we'll activate the service. Once activated, we're then going to browse to the Connect option in the left-hand side menu under Global Secure Access, and then under Connect we're going to click Traffic Forwarding. Within here we're going to activate 2 traffic forwarding profiles, the first one being Microsoft 365 Access profile and the second one being the Private Access profile. Once both of those profiles have been enabled, we're then going to look at enabling source IP restoration. Source IP restoration is required to fully benefit from conditional access integration with Entra Private Access, as well as to support integrations with continuous access evaluation and identity protection, all of which are highly recommended and fundamental benefits of the SSE solution. Source IP restoration restores the source IP addresses of the original egress IPs, which in turn improves security logs, such as those found in Entra ID sign-in logs, and upholds integration with conditional access components, such as named locations, as well as identity protection elements, such as location-based risks. To enable source IP restoration, browse to Global Settings, still underneath the Global Secure Access menu tab, and then within Global Settings click Session Management, and then within Session Management click the Adaptive Access tab. Within there we're going to enable Global Secure Access Signaling in Conditional Access, and then we're going to click Save. Okay, so now that the service has been provisioned, it's time to deploy our first private network access connector. These connectors are essentially lightweight agents that reside on your on-premises Windows servers and provide that much needed outbound connectivity to the global secure access service, which then facilitates and brokers any remote connectivity to internal resources. It's important to understand that these servers that will host the agent need to have visibility to the servers or the internal resources that you want to grant access to. If you've ever deployed Entra Application Proxy, previously known as Azure Application Proxy, you'll already be somewhat familiar with this process. The agent is a later and more feature-rich version of the original Application Proxy one. If you have already got a previous Entra Application Proxy agent installed, you can simply reinstall it to get the latest version that supports Entra Private Access. At the time of recording, you'll also need to manually delete any corresponding folders when uninstalling the older version before installing the later one. The service supports the installation of multiple connectors, but also works with just the one. In a production environment, we do recommend having multiple connectors spread across multiple connector groups. Not only do multiple connectors instill resilience by introducing an element of redundancy if another connector fails, but groups also allow you to handle and segregate traffic between different internal resources, such as applications. For the purposes of this recording and initial proof of concept walkthrough, we will create a new connector group, but we will only install one single connector. Please note, as previously mentioned, that this is not generally recommended for a production deployment where multiple connectors and multiple connector groups should be adopted. Within the Microsoft Entra blade, entra.microsoft.com, we're going to navigate to Global Secure Access once again. Within Global Secure Access, we'll navigate to Connect, and then within Connect, we will click Connectors. We can see currently that there is an inactive connector. We can just ignore that for now because that was from some previous testing. And now we'll navigate to create a new connector group. Within the flyout window pane, we'll give the new connector group a name. Here, you could also choose the connectors that you want in scope for the group, but we don't have any active ones just yet. And then we'll just check over the advanced regional settings and then click Create. And here we go, we can see our new connector group here. The next step is to download the connector service, so this will be the agent that we install on the server. Within the flyout window pane, we'll review the system requirements, installation instructions, and the terms of service, and then we'll click Accept Terms and Download once we are happy. Once the connector installer has downloaded, we'll run this as an administrator. We'll now follow the installer wizard. When prompted, please authenticate with a Microsoft 365 account that has either Global Administrator privileges or Application Administrator privileges. And there we have it, our first private network connector has been installed. We can verify this by refreshing the page. Here, we're going to move the connector into the new connector group that we created. As we can see, the connector is active. And there we have it. In this next section, we'll look at defining, configuring, and publishing the applications and services, being the internal on-premises resource that we want to grant access to for our end users via Entra Private Access. In this example, we will create two applications. Application 1 will be called Private Access-File Server, which will facilitate SMB and RDP access to an internal and on-premises file server. Application 2 will be called Private Access-App Server and will facilitate HTTP access to an internal and on-premises web application on an application server. This means that Application 1 will provide access to ports 445 and 3389, whereas Application 2 will provide access to port 80. And just before we delve any further, it's important to note that there are two options available to publish access to internal resources, one being via the Quick Access function and the other being via the Enterprise Applications function. The Quick Access method is tailored towards hosting a foundational group of fully qualified domain names and/or IP addresses that you may want to secure and provide access to on an underlying basis, and by foundational, we are referring to those baseline resources which you always want to direct through the SSE service in a blanket fashion for all users and devices using the same security and access settings. Thinking ahead to the future, Quick Access would likely accommodate items such as private DNS, which would reflect a one-for-all type policy. The Enterprise Application method, on the other hand, is tailored towards providing a much more detailed and granular approach to securing, managing, and granting access to internal resources as multiple per application and private access policies and different subsets of conditional access policies can be created and then scoped to different users thereafter. For this technical demonstration, we will continue with the Enterprise Application method, as the technical configuration follows the same concept as the Quick Access configuration at the time of recording, but also enables us to be more flexible later in the process, therefore offering a fuller illustration of the wider process. Essentially though, if you can configure one, you will be able to configure the other. Back within the Microsoft Entra portal, we're going to navigate to Global Secure Access once again, and then we'll click Applications within. Here, you'll be able to see the two different options we've just talked about, quick access and enterprise applications. Within the quick access configuration page, this is where we could configure any blanket one for all type policies. Navigating to enterprise applications, this is where we can create and define applications and resources in a more granular fashion. Within here, we're going to click New Application. We'll start off by giving the application a friendly name. In this instance, we're going to create the first application for the file server, so we'll call it Private Access -File Server. We're then going to choose the connector group we created and defined earlier. We'll then verify that Enable Access with Global Secure Access Client is enabled, and then we'll click Add Application Segment. Within the destination type field, we have 4 different options to choose from. The first one is IP address, which reflects the internal IP address of the resources, such as 10.1.130.20. We then have fully qualified domain name, which reflects the internal FQDN of the resources, such as servername.domain.com. We also have IP address range, CIDR, which reflects the internal IP address range of the resources in CIDR format using a network mask, such as 10.1.130.20/28. And then finally, we have IP address range, IP, which reflects the internal IP address range of the resources in IP format using a starting IP address and an ending IP address, such as 10.1.130.20 to 10.1.130.30. In this example, we're going to use the fully qualified domain name of the server. Next, we'll define the ports that we want to grant access to. As we want to provide SMB and RDP access, we'll type 445,3389. For multiple ports, simply separate them using a comma. And here we are. We can see our first application has been defined. It's as easy as that. Once the application has been created and saved, we'll browse back to Enterprise Applications to open the application that we just created. If you've ever dealt with enterprise applications before, such as those directly configured and managed within Entra ID, this screen will be very familiar to you already. Starting within the Properties tab, we're going to pay attention to 2 settings. One being assignment required, which determines whether the application should require users to be specifically assigned to it to grant access, or whether all users should have access by default. If set to yes, to require user scoping, this is configured within the Users and Groups tab. The next setting is visible to users, which determines whether the application should be visible to the in-scope users, i.e. from the My Apps portal, myapps.microsoft.com. For this use case, there is no real requirement to or purpose in having the application visible to users. In this example, we have opted to scope the application to specific users only. And because we have done that, we'll now browse to the Users and Groups tab, where we can specify which users or groups we want to have access to this application. We'll click Add User Group, and then we will search for the users and groups that we want to grant access for. And that's it. All we need to do now is repeat that exact same process for any other internal resources that we want to provide access to. As we discussed at the start of this section, we'll be creating 2 applications, one for the file server that we have just created, and then one for the application server, which we'll now do very quickly. The application will be called Private Access -App Server, and then the application segment will be using an IP address of 192.168.130.10, and the port that we'll be granting access to will be port 80 because it's a HTTP web application. The final step before we can test and prove our implementation of Entra Private Access is to deploy the Global Secure Access Client or agent to the end user endpoints. Much like many other client installations, the Global Secure Access Client is no different in that it can be downloaded and installed manually per device, but it can also be deployed centrally via tools such as Group Policy, Microsoft Endpoint Configuration Manager, or Intune. In this example, we are going to use Intune along with the Win32 application management and packaging capability to deploy the Global Secure Access Client to our test device. Back within the Microsoft Entra portal, entra.microsoft.com, we're going to navigate to Global Secure Access once again. Within there, we'll click Connect, and then we will select Client Download. We'll then locate the Windows client and then click Download Client. Once the client has been downloaded, we'll then use the Intune Win32 packaging tool to package the executable. If you are unsure on how to use the Win32 packaging tool, I'll leave a link to Microsoft's documentation in the description. Once the installer has been packaged into an Intune Win file, we're then going to browse to the Intune portal and then go to Apps and then Windows Apps and then click Add. We'll then select the Windows app Win32 application type. Now we're going to upload the Intune Win file that we have just packaged. We'll then give the application a friendly name and then provide a publisher. We'll then specify the install and uninstall commands for the application. You will find these in the description of the video too. However, if you did want to customize this, you can always run the executable within command prompt using the question mark switch. You'll then be presented with all the different install options. Next, we'll specify the relevant system architecture and minimum operating system for the client, and then we'll specify the detection rules. And for this detection rule, we're going to choose the file rule type. We'll then check whether a certain executable that belongs to the Global Secure Access client is present on the device. Again, I will put this criteria in the description. Finally, we'll proceed through the next screens and then assign the application to our test device. Next, on our test device, we're now going to force a synchronization to Intune to make sure that it receives this new application deployment. We can see here that the application is now downloading and installing. Upon a successful installation of the client, the end user will be prompted to authenticate with their credentials, as we can see now. If the user is using a hybrid joined or fully Entra ID joined device, they'll have their username already populated. They simply just need to click it. And then repeat that step to authenticate once more. And as we can see here, the Global Secure Access client has now installed and is connected. And now it's time to prove a concept, the moment of truth. In this demonstration, we have an Entra ID or Azure AD joined endpoint. There's no hybrid join and there's no Active Directory domain services domain join either. And our test user is directory synchronized via Entra Connect, also known as Azure AD Connect. The device is currently connected to the local area network, so if we try and ping the file server, we'll get a response as expected. And if we try and ping the domain controller, again, we will get a response. If we quickly take a look on the file server, we can see the share here. This is the folder structure that we will be accessing. And if we use the local loopback address, we can see that the share is currently shared out. Taking a look on the application server, we can see in IIS that we have a HTTP application here. Now, if we go back to our client, we'll disconnect it from the local area network and connect it to a completely isolated one to reflect a remote access or work from home scenario. Here, we'll try pinging the file server again, and as expected, we don't get a response. We'll try the domain controller also, and as expected, no response either. One more thing we'd like to check before we start is if we go to the Global Secure Access client and click Advanced Diagnostics. We'll then navigate to the Forwarding Profile tab, and within there, we'll verify under Private Access rules that the configuration we implemented earlier is present. And we can see here that it is. Now, let's browse to the file server via the SMB protocol using its fully qualified domain name. And as we can see, we have managed to get remote access to that internal and on-premises file server without being connected to the local area network. To further prove the concept, we'll create a new folder. It's worth noting that you can also map a drive via the fully qualified domain name, which will automatically connect upon user login. Next, we're going to try and use the RDP protocol to remote desktop onto the file server. We can see here that the connection has been established and we're now going to authenticate. And there we go, another successful test for Entra Private Access. We'll just browse through the file server now and verify that that new folder is there that we just created. The final test will oversee us opening the web application, which if you remember is mapped by its IP address. And there we have it, 3 out of 3. Let's now look at another key benefit of the Entra Private Access solution, aside from its ability to provide remote access, which is its ability to integrate seamlessly with conditional access. And yes, you heard that right. When using Entra Private Access to facilitate remote access into on-premises and internal resources, we can actually use conditional access to enforce controls around this access, such as grant controls such as multi-factor authentication and ensuring device compliance, as well as session controls such as sign-in frequencies. In this example, we are going to require that users who are connecting to the on-premises and internal file server via Entra Private Access must be using a compliant enrolled device and must have also satisfied MFA. This can be achieved by scoping the new conditional access policy to the enterprise application we created earlier, called Private Access-File Server. If we now try and access the file server via the SMB protocol from a non-compliant device, we will subsequently be blocked and presented with this compliance error. And as with any other Microsoft 365 sign-in activity, we can review this failed access attempt within Entra ID's sign-in logs. Now, moving on to how we can monitor and report on the solution once it has been implemented, there are 2 locations where we can find reporting and log components for Entra Private Access, one being client-side and the other being service-side. Within the Advanced Diagnostics component of the Global Secure Access client, if we browse to the Traffic tab, we can gain an overview of all traffic that has recently traversed the Global Secure Access client and solution for this individual endpoint only. From here, we can review the data, collect it, and export it to a CSV. For example, here we can see the RDP and HTTP traffic from our testing. On the service side, back within the Microsoft Entra portal, entra.microsoft.com, we can once again browse to the Global Secure Access menu option. Within there, we're going to click the Monitor option, and then we are going to choose Traffic Logs. Within here, there's a few available filters such as Internet Access, Private Access, and Microsoft 365 Access. We're going to choose Private Access, and then we're going to select the columns that we want to see. Here, we can see all the traffic that has traversed the solution from our test endpoint. From here, we can review the data and also export it to a CSV or JSON file. The future is certainly bright for Entra Private Access. We only need to absorb everything in this video to understand its full potential both now and in the future. However, we must remember that although already impressively comprehensive in its capabilities, at the time of recording, this feature is still in public preview, with certain features still locked behind a private preview. This is only phase 1 of the solution today, meaning there is a lot more of this to come. Within one of the recent Microsoft Mechanics videos, Microsoft has already stated that the solution now supports private DNS traffic over port 53, as well as Kerberos over port 88, and we are talking about UDP here, as well as TCP. Unfortunately for me, at the time of recording, this is still locked behind a private preview, so I haven't been fortunate enough to get my hands on it. This new support is particularly exciting and important for Entra ID joined devices using Windows Hello for Business, where a Kerberos ticket needs to be granted to successfully and seamlessly access resources such as NTFS file shares, potentially alongside Cloud Kerberos Trust. As of right now, this is not supported, and instead, the Entra ID joined device must be logged into via the end user's Microsoft 365 username and password to gain seamless access. I do just want to clarify one nuance that currently exists, which is that our test device was logged into using the test user's Microsoft 365 username and password, and not Windows Hello for Business. If the latter is used currently, authentication fails, with a similar experience to that if you don't have Cloud Kerberos Trust implemented. This nuance will hopefully be accounted for in the future, and as already mentioned, has been hinted in a recent Microsoft Mechanics video. Additionally, it doesn't look like the client can auto-update itself on end users' machines just yet, which means manual input is required to update the client currently, whether that be manual or through supersedence rules in Intune, for example. I'm sure this is something Microsoft will introduce later though. Another nice benefit would be the ability to silence the initial sign-in and authentication prompt once the client first successfully installs. assuming there is a logged in user of course. Finally, what will likely be a make or break decision for many organisations is still unknown, and that is a pricing and costing model once the solution transitions out of public preview and into general availability. All in all though, a fantastic and much welcomed addition to the Entra family, with super exciting developments still to come. Okay, so that's everything for today's video. As a recap, we've taken a look at what the Entra Private Access solution actually is. We've taken a look at how we can implement and configure the solution. We've also looked at how we can manage the solution thereafter. Hopefully you found this video useful and insightful, and as always, thank you very much for watching.